So guys, yeah, here we have another soft starter. This one is ABB PSE. Already this one we dealt with. We have dealt with it several times. Yeah, this is not the first time. Actually, it's running a fire pump. It's running a fire pump. This motor is, I think, 132 kilowatt. You can see, and the maximum amp is 234. The voltage is around 380 definitely, and we have the RPM 2975. So this is for the pump. This one is for the jogi pump, and that one is the engine. So all of them, there are 3 pumps in total. So in case one pump, in case maybe they want to put off the fire, when there is no electrical, they can use the engine. If there is no demand of a lot of water for putting off the fire, the jogi will start. But still, if they need more water, a lot of water, then this big one will take over. So this one is small, this one will take over. That one, in case there is no electrical totally, maybe the whole building is shut off, the engine option will run. This one, in case they need not too much water. And this one is for in case they need more water. That one we know, of course, that one is, this one is booster pumps. That's nothing to do with this one. Now this one, this for monitoring. That is the power factor. That is the percentage when it's running, and that's the voltage. Yeah, the voltage. So that is the amps when it's running. And we know the program. This one we have done so many times. So that's where you set, the first one you set the full load amp of the motor. And that one is okay. Then the second one is the acceleration of the ramping up time. That one is the deceleration time. We had an issue with the deceleration time. It was showing EF14. EF14, it indicates the motor was stopping all of a sudden without ramping down. It should decelerate when stopping down. But in this case, it was just stopping abrupt. And that's why the fault was indicating EF14. Then that one is the percentage of the voltage. That one is, depending on your load, you can set how many times the full load amp it will take when starting. In our case, the maximum amp is 234. So 234 multiplied by 4 is around 1000 amps when starting. Okay, that one is about, already I had explained that one in my previous video, so I won't repeat that. I don't have to repeat that. And that one also, you can check from my previous video. Yeah. And the 10 seconds also, yeah. So these other ones, I don't have to repeat. That is the most important. The second one, the deceleration and the percentage, and that one. Actually, 1, 2, 3, 4, 5. They are the most important ones. So in this case, we are going to do a little test. We see how the starting amps, it will start, it will go 4 times up, then suddenly it will go down. Now we can test our load. Yeah, I had switched off here. Let me switch on. So I run it manually here. And the motor is starting. So our arms is going almost 1,000. Then it is going down. Now it has gone down. And the conductor has engaged, yeah? So our motor is running. Then it will stop softly before it was stopping like a top. And was causing problem. Yeah. Okay. Now I stop it. Now it will go up, the current will go up, then suddenly it will go down. Stop the current. And it has stopped. So let me check for you another thing. We have just jumped. I have to explain. Yeah, like I was saying, the first one is the amps, the second one is the ramping up time, ramping down time. Okay, that is a percentage, and that is the times the full load amp. Then there is torque during stop. That is the torque during stop. We don't need the torque. Torque during off, during start, during off. Then we have the kickstart. Also, we put it off. That is the kickstart. Then electronics overload. We want to reset using hand. That's why you set 10. Then we have underload protection. We put it off. When the load is low, we don't want it to switch off. Then we have locked rotor protection and the field bus control. We don't need all that. Okay, thank you guys. Okay, see you next time. Okay, bye.